Let's just go through briefly the brief notes that I've made for each topic. I'm going to explain each one of them point by point so that when you download them, you're able to understand what we are talking about. So these notes are on the first unit, which is motion, force, and energy. And I wanted you to be able to understand what is speed, that is how speed is defined, being distance per unit time. In other words, the ratio of the distance to time. Sometimes we say this is the rate at which the distance changes, or the distance covered per unit time. All these are acceptable definitions. Distance per unit time, distance covered per unit time, the ratio of the distance covered to time taken to cover that distance. All those are definitions of speed. When we say what something is, when we use this word, when we say what something is, we are defining it. So the equation which comes directly from the definition of speed is this one here. Speed is equals to distance over time. And in symbols, we have V is equals to D over T. This one is in symbols, okay? So because I'm basically explaining, when I say that this is the case, sometimes we can even say V, which is speed, is equals to distance, which can be replaced with X, of course, divided by time. And I find that in the syllabus, they've even given us S over T. S is a symbol for displacement. Like I've said in the notes, the symbol for speed is V, not S. First of all, don't use S to symbolize speed. Where S is used, it is used to symbolize the magnitude of the displacement. The magnitude of the displacement, which is basically distance. Okay, so where S is used, we are talking about the magnitude of the displacement. Remember that. There is another physical quantity we call average speed. Average speed, which is total distance covered divided by the total time. So when we look at the complete motion from the beginning all the way to the end, what is the total distance covered and what was the total time taken? When we get the ratio of the total distance to the total time, we're actually calculating the average speed. This one is different from instantaneous speed at a given instant of time. We will meet that particular term later on. So let's look at a speed of about 5 meters per second. What does 5 meters per second stand for? If you're told that the speed of an object is 5 meters per second, it would mean that the object covers a distance of 5 meters in 1 second, or a distance of 2.5 meters in 0.5 of a second, or a distance of 10 meters in 2 seconds, 15 meters in 3 seconds, 20 meters in 4 seconds. What you will observe is that it covers a certain equal distance in equal intervals of time, because you can see the time interval here. Let me just erase this because I've inked it by mistake. You can see that the interval of time being considered here is 1 second, 1 second, 1 second. And when an object covers equal distance in equal intervals of time, we say that its speed is uniform. And should we plot a graph of distance versus time, you'll agree with me that actually for me to get these points, this particular points here, you would be able to see that actually we are talking about after 1 second the distance covered is 5. After 2 seconds it will be 10. After 3 seconds it will be 15. Just like in the table, when we plot such a graph, we get a straight line like that. When a distance time graph has a straight line, then it means that its gradient, which is change in the quantity on the y-axis divided by change in the quantity on the x-axis, that is how we work out the gradient, will represent speed, How is that possible? You find that this change on the y-axis is in meters. The gradient is equal to the speed, because you find that that change in distance divided by change in time, this one will be in meters, this will be in seconds, and you see we get a physical quantity whose unit is meters per second, whose unit is the same as that one of speed. And that is why we say the gradient of a distance time graph represents speed. This one is so important. It is even emphasized in the syllabus, and they always test this aspect. So first of all, you should be able to know how to calculate the distance, or how to calculate the gradient. You should know how it is obtained from this graph. You should know, you should draw a right-angled triangle, and then get the change here. This triangle here called delta means change in D. How do I get that change in D? I get this D over here, which would be 35 minus 10. I'm going to get 25. And then I get this time here, which will be 7 minus 2, which will be 5. And let's just do it, because this one will be 35 minus this one here, which will be 10. Divide by, this is 6, this one is 7, minus this one, which is 2, and you can see I'm getting 25, of course, meters, divide by 5 seconds, and you can see that is what gives me 5, because 25 divided by 5 is 5. Meters divided by seconds is meters per second. You can see by working out the gradient, I'm getting actually the speed which I used to plot the same graph. And that is proof that the gradient of a distance time graph represents speed. So let's look at this point here that I regarded to be very important here. To describe a distance time graph, one must attempt to describe how the gradient changes with time. So important. Like for example, here you can say the gradient is constant, or the gradient is uniform. The moment I say the gradient is constant, then I just need to replace the word gradient with the word speed, as we are going to see in the next page of the notes. And remember, these notes are free of charge. You can go to the video description and be able to download these notes. So this one is again distance, time. So let's look at the object A. We can see that the gradient is constant. So our description, we are going to say constant speed. Let's look at B. Again, the gradient is constant. Again, we're going to say constant speed. But how is the constant speed of object A different from the constant speed of object B? You can see that A is more steeper than B. In other words, the value of the gradient of A is larger than the value of the gradient B. I like the word steepness. This one is steeper than this one. And therefore, since it has got a larger gradient, A has got a larger gradient, then the speed of A is greater than the speed of B, because the gradient of A is greater than the gradient of B. That is how they compare. Let's look at C. Object C has a graph whose gradient starts from 0 and then it increases. That gradient is going to increase. So the gradient is increasing. Since the gradient is increasing, we replace that increasing gradient with increasing speed. We're going to say that the speed is increasing, and any speed which is increasing is referred to as an acceleration. Let's look at D. Again, D, we start with a point whereby the steepness is very high, the graph is very steep, but as we go towards, as time changes, the steepness is reducing, the steepness reduces. And in order to get the steepness or the gradient of a curve at a point, we usually put a dot there, and then we draw a tangent. You draw a tangent there, then you get the gradient of that tangent just by drawing a right angled triangle like that. And then you get the value of change in D divided by change in T. And remember, what we are talking about is the gradient at this particular point where there is the dot. Yeah, so you draw a tangent, find the gradient of the tangent. If we come to some point here, you agree with me that if I draw a tangent at this point, it will be less steep compared to here. You can see the steepness here and the steepness here. So as time increases, the steepness is going to decrease. What does the steepness or the gradient represent? The steepness represents the speed. So for D, we can see that the steepness is decreasing, or we can say the gradient is decreasing. Better still, we can say the speed is decreasing. Decreasing speed, and a decreasing speed is referred to as a deceleration. Let's look at E. In E, you can be able to see that it's got uniform gradient, but that gradient has got a negative sign. The negative sign will show that the object is moving back towards the point where it started from. If the object started from a certain point, let's say maybe it started from, let me use a different color here. Let me say it started from this point and it is moving in this direction like this, and it has moved until it reaches somewhere around here. Now, when we start timing, so the object is moving back. Since it is moving back, you can see that the distance is reducing. The distance is reducing. Like you can see here, when we start timing, the distance is very large. But as time increases, the distance increases. You can see that. As time increases, the distance is decreasing. So the negative sign shows that it is moving towards the starting point. Moving towards the starting point. So there I've mentioned an instant of direction. So I'll come to this later when I talk about the velocity. But at this point, let's look at some questions where we are going to employ these facts that we've talked about in this video. Okay, let's look at this first exercise here, where we are told that an object covers a distance of 10 meters in 5 seconds. Calculate its average speed. So this is time. The time is 5 seconds, while the distance is 10 meters. So speed, which is V, is distance over time. So if it is average speed, then it is total distance over total time. And this one will be 10 meters. Of course, divide by 5 seconds, and you get 2 meters per second. And it's just as simple as that. Let's look at question number 2. The graph shows the motion of an object. Describe how the object is moving in each section of the graph. When you are asked to describe how an object is moving, you are expected to mention how the physical quantities such as distance, displacement, speed, velocity, acceleration, how those physical quantities are changing with time. So let's look at the section OA. When we look at this point, we have, first of all, we remember that the gradient or the slope of a distance time graph represents speed. So if we attempt to draw a tangent at point O, we find that it is parallel to the t-axis. So definitely this object has got 0 speed when time is 0, and then that speed increases because the gradient of this graph is increasing. Remember, the gradient represents speed. So we can say that in OA, object starts from rest, and moves with increasing speed. Moves with increasing speed. Increasing speed. Yeah, the speed is increasing because the gradient is increasing. In AB, we can see that the gradient is constant. So we are going to say it moves with a constant speed. Constant or uniform speed. BC, we can see that the speed is going to decrease because the gradient is decreasing. As a matter of fact, at point C, the gradient is 0. So the object's speed decreases to 0. Moves with decreasing speed. Decreasing speed. And remember, when we say that this is constant speed, then acceleration is 0. When we say that the speed is increasing, it is accelerating. And here speed is decreasing, it is decelerating. So accelerating, acceleration is 0. Decelerating, so decreasing speed, and then comes to rest. Decreasing speed, it eventually comes to rest. Remember here, it started from rest. Let's look at CD. CD, the gradient is 0. That means speed is 0. Object is at rest. Object remains at rest. So remember, when you're asked to describe how an object is moving, look at the words that I've used. Here, I have found it appropriate to use the word speed, speed, speed throughout, because I know the gradient is represented, the gradient represents the speed of the object. So what I want you to take away from this lesson is just to recall that the gradient of a distance time graph represents speed. And the moment you describe how the gradient is changing, you replace the word gradient with the word speed. For instance, here the gradient is increasing. You are going to say the speed is increasing. The gradient is constant. You're going to say the speed is constant. The gradient is decreasing. You're going to say the speed is decreasing. The gradient is 0. You're going to say the speed is 0. Consequently, it means the object is at rest. And that is how you would answer these questions. So go right ahead, download this exercise from the description of the video and repeat those questions.